Okay, let's look at this question 2. WASSCE June 2007 question 3. The tangent to the curve y is equal to x squared plus bs, where b is constant at x equal to 1, passes through the points a minus 1, 6 and b 2, negative 15. Find the value of b. Okay, so when you look at the curve, okay, the tangent to the curve, the line which is tangent to the curve, this is the curve where b is constant, the b here is constant at, so the line is tangent to the curve at x is equal to 1. Okay, so at the curve, the line touches the curve at x equal to 1, but the line also passes through this point, negative 1, 6 and then 2, negative. Find the value of b. So what we are going to do is that, okay, when you look at as the line is passing through a and then b, okay, then we can find the gradient, okay, of the line from this a and b. Okay, so we can find the gradient from here, and then when we find the gradient from here, all right, then we can also find the gradient, okay, from the curve given here. So when you differentiate, you get the gradient function, and at s equal to 1, when you substitute into the gradient function, it will be equal to the gradient of what? The line which is tangent and passes through the point a and then b. Because the line which is tangent, when I have my tangent like this, okay, then on this particular line, you can find the gradient at any point on the line because it is the same line, all right. And then the line is tangent to the curve at, let's say, the point at where s is 1, okay, where s is equal to 1. And on the same line, we have these 2 points a and b. Okay, it means that at where s is equal to 1, when I differentiate the this, I'll get the gradient function and substitute here to get the gradient. And at the same time, I can use the point a and b to also find the gradient, because on this line, which is the tangent, you can get the gradient from any of the points. I believe that is clear. All right. So what we are going to do is what? Is to, we have the curve as y is equal to x squared plus bx. So we are going to differentiate this to get the gradient function, and that will give us 2s plus b. All right. Then at s is equal to 1, what will be our gradient? Okay, you said it touches the curve at s is equal to 1. That is the line. Okay, so our gradient will be 2 times 1 plus b, and that will be what? 2 plus b. 2 times 1 plus b, that will be 2 plus b. All right. So this will be our gradient, okay, at where s is equal to 1. Then the same tangent passes through the point a and b. Okay, so at point, you say at point a, negative 1, 6 and b 2, negative 15. What will be our gradient? Our gradient, we know, is what? 2 points, y2 minus y1 on s2 minus s1. I believe you remember this. When you are given 2 points, how you find the gradient? All right. So our gradient can be what? What is, so let's say this is my s1 y1, s2 y2. Okay. So minus 15 minus 6. All right. Divided by 2 minus 1. All right. So my y2 minus my y1 minus 15 minus, and then my s2 minus my s1. All right. So minus 15 minus 6 will give me what? Minus 21. And then 2 minus 1 will give me 3. So the gradient is going to give me what? It's going to give me minus 7. Okay. So the gradient of the line is minus 7. And the line passes through the curve at s equal to 1. And this is the gradient. So we can say that, therefore, 2 plus b is equal to what? Negative 7. And my b is going to be negative 7 minus 2. And b is going to be negative 9. So the value of b is negative 9. The value of b is negative 9. I hope this is clear and understood. I will see you again in our next lesson. Bye-bye.